everyone. My name is Akshay Konagalla. First of all, I would like to thank my professor for giving me this wonderful opportunity to present my project on artificial intelligence for natural language processing. In this presentation, I will be talking about how artificial intelligence has transformed the way machine understands and interact with the human language. We will explore the journey from the early root-based system to advanced AI models like transformers, BERTs, and GBTs that powers real-world applications. So let's begin by taking a quick look at the content of my presentation. Here is an overview of what we will be covering today. We will begin with an introduction to NLP and AI, followed by its importance in today's world. Then we will explore the evolution of NLP from early rule-based system to the era of machine learning and future learning. Next, we will see how AI transformed NLP with the introductions of deep learning models such as RNN and LSTMs, attention mechanisms, and the transformers. We will also discuss popular models like BERT and GPT, as well as large language models that powers most modern applications. Finally, we will look at NLP's real-world applications, benefits, challenges, and future directions before concluding this presentation. Now let's start with the basics and an introduction to NLP and AI. Natural language processing or an NLP is a field that helps computer to understand, interpret and respond to the human language. It analyzes text and speech to find meaning, intent and context, the same thing the human naturally understand. Actually, artificial intelligence strengthens NLP by enabling machines to learn patterns from massive amounts of data instead of relying on manually written rules. Techniques like tokenization, stemming, and lemmaization simplify language with semantic analysis helps to identify the relationships and the meanings. Together, AI and NLP makes applications like translations, summarizations, and chatbots possible. Next, let's look at why NLP is so important in today's data-driven world. NLP plays an essential role in helping humans and computers to communicate effectively. It extracts useful insights from large amount of unstructured text such as emails, reviews, or documents. Search engines use NLP to interpret our queries and deliver relevant answers. Sentiment analysis helps organizations to understand public opinions and emotions from social media. Name entity recognitions identifies the peoples, place, companies mentioned in the text and improving the information extraction. NLPs also power chatbots and virtual assistants, making human-computer interaction occurs more natural. Now that we know its importance, let's take a look at how it all started with an early rule-based NLP systems. The first NLP system relied entirely on handwritten grammar rules and word dictionaries. Chatbots like Eliza could mimic conversations but could not understand content and complex language. These systems were limited, they could not learn from the data and had to be updated manually for new words or the slang. Because of this, performance was hard and hard to scale. Still, these rules-based systems provides the foundations for everything that came later. With that background in the mind, let's move on to the next big steps in the machine learning in the NLP. Machine learning changed everything. Instead of depending on the fixed rules, model began learning directly from the data to find the language patterns. Algorithms like Navy-based support vector missions were used for the test classifications and the spam detection and sentimental analysis. Supervised learning allowed models to recognize entities and understand topics more accurately. As data grows, these models adapt and improve on their own, making NLP systems smarter over time. This leads another key development. Future engineering, which we made missions understands in the numerical forms. Future engineering is all about converting into the numbers that a computer can understand. The back of word model could often word appeared while the term frequencies gave more importance to unique words. Later, word embedding like word to vector capture relationship between the words and a helping system to understand similarity and the context. This made tasks like classification, clustering, and document retrieval much more accurate. Now that we have seen how words are represented, let's discuss how AI completely transformed the NLP. Artificial intelligence revolutionary NLP by manually written logic codes with the systems that learn automatically. Machine learning introduced patterns recognitions, while deep learning helped uncover complex meanings in that context. AI powered NLP can now understand the ambiguity and emotions, even the data that in hidden patterns. Attention and the transform models make it possible to analyze the huge datasets effectively, and models like GPTs can include multiple tasks such as transactions, summarizations, and conversations. Now let's move deeper into the world of deep learning with the neural networks, which is also known as recurrent neural networks. Recurrent neural networks, or RNNs, were designed to handle sequence of text while the order of words matters. They remember the previous words to understand the context in a sentence, which is useful for the speech recognition and the text prediction. However, RNN struggle with a long sentence because earlier words were often forgot due to the vanishing gradient. Despite that, they played major role in advancing language understanding. Next, we will see how the LSTMs solved this memory problem and took RNN a step further. LSTMs are improved versions of RNN that they can remember information for longer sequence. They automatically decide what information to keep or what to forget. This made them very effective for the tasks like transactions and chatbots that need long-term content. When combined with this attention mechanism, they perform even better in understanding the longer content. Let's move on to the next topic that truly reshaped NLP, the attention mechanism. The attention mechanism helps models focus on the most important word in a sentence. It assigns weights to each word depending on its importance to the meaning. This improves accuracy in the translations, summarizations, and question answering. Attention also enables faster parallel process, making large-scale NLPs much more efficient. It became the key component behind the most powerful architecture in NLP. So it's also the name mentions called as the transformers. So let, let's discuss how the transformers changed NLP forever. The transformer models process all the words at once using self-attention. This allows it to capture long distance relationship between the words across an entire paragraph. It made training faster, more efficient than older models like RNN and LSTMs. Transform-based models such as BERT, GPTs, and T5XLs at transactions and the summarizations and comprehension. They have become the foundation for nearly all modern NLP advancements. Now let's explore one of the most important transformer BERTs. So bidirectional encoder representations, also known as BERT, reads the text in the both directions from the left to right and the right to left to understand the full content. It's pre-trained on large amount of text and fine-tuned for the specific task like question answerings and the classifications. Because it can understand the relationship between the words so deeply, it delivers high accurate results. And BERT is widely used in the search engines, chatbots, and other NLP systems. Now, we talk about another GPT, another revolutionary model that focuses on text generation. GPT is designed to generate text that sounds human-like and contextual accurate. It predicts one word at a time based on the previous ones, allowing it to create a complete sentence and the paragraphs. GPTs can summarize documents and generate stories and even write the computer code. It widely used in the content creations and customer supports and conversational systems. After GPT, the field moved even larger models known as large language models, which is also known as LLMs. Large language models are trained on a massive data sets and can perform many NLP tasks simultaneously. They handle translations, summarizations, reasoning, and text generations, all with the single model. These models can deeply contextually understand and adapt easily to specific domains. LLMs are mostly of today intelligence systems is like chatbots and virtual assistants. Now let's explore how AI powered NLP is being used in the real world applications. AI and NLPs are making impact across many fields. In healthcare, they help doctors to analyze the patient records and summarize the systems. In the finance, they can detect the fraud detections, and interpret the financial news. In educations, they can evaluate, assess, and provide personalization feedbacks. In the laws, they can summarize the long contracts and identify the key clauses. In entertainment, they also help to create a script, subtitles, and the lyrics. So now let's discuss one of the most common applications on the chatbot and the voice assistant. So AI-powered chatbots and the voice assistants are the most familiar examples of NLP in the daily life. They understand, response to the user questions naturally using AI-powered speech recognitions. Assistants like Siri, Alexa, and Google Assistants can perform tasks and answer queries, even understand the emotions. They keep conversations coherent and improve over time as they learn from the users. Now let's talk about how NLP works across multiple language through multilingual models. So the multilingual NLPs are helps system to understand, translate text across different languages. Models like MBRTs and can process more than 100 different types of languages effectively. Cross-lingual embedding also knowledge sharing between languages between translation accuracy. This improves global accessibility and breaks communications barriers. Now let's explore the key benefits of using AI in NLP. AI enhances NLPs by improving accuracy, speed, and efficiencies. Pre-trained models like BERT and GPT save time and resources by learning from huge datasets. AI enables automations in summarizations, classifications, and sentiment analysis with the human efforts. It supports multilingual communications and making technology globally accessible. But along with these benefits, AI also faces some certain challenges. Let's discuss them next. Even though AI has made NLP powerful, it still faces challenges. Models can inherit bias from the training data and lead to unfair results. They require a lot of computational resources and energy to train. Sometimes model generates text that looks correct but is not accurate. Privacy or ethical concerns also need careful attention. Now let's see ahead how the future of NLP is being shaped. The future of NLP focuses on making models more efficient, ethical, and understandable. Researchers are developing lightweight systems that reduce computational cost. Efforts are being made to explain how AI makes decisions for better trust and transparency. Combining the text with the audio and visuals will lead to more advanced multimodal AI. Ethical AI will aim to reduce bias and protect privacies. Finally, let's wrap up with a short conclusion. To conclude, artificial intelligence has completely transformed natural language processing. We move on from the rule based system to intelligent models and capable of understanding and generating reasoning with the human language. Although challenges like bias privacy remains, ongoing researchers making NLPs more ethical and powerful. So, future AI powered NLP systems will be more adaptive, multilingual, and content aware. Overall, AI is the key to unlock smarter, faster, and more human like natural language processing. I would thank you all. Thank you. I would like to again thank to my professor for this opportunity and for the constant support and guidance. Thank you all.